Today's topic is maximum power transfer theorem. In this topic, we are discussing about the maximum power transfer from source to load. We know an electric circuit comprised of mainly three parts. One is source, then load, and a connecting circuit or closed circuit. Source and load should form a closed circuit. Then we can say that this is an electric circuit. In the maximum power transfer theorem, we are discussing about the maximum power transferred from source to load. In this video, we are discussing about a DC source and a DC load. Okay, the source may be DC source, AC source, or similarly, load may be DC load or AC load. In this topic, we are discussing about the DC source and the maximum power from this DC source transferred to the DC load. Okay. First, we can replace this DC source or DC source network with the equivalent voltage source, that is current equivalent circuit V0 and RTH. And to the equivalent circuit, we connected the load. That is, this circuit is similar or equivalent to this circuit. These two circuits are equivalent. Now, from the source, current delivered to the load is equal to I, and that I, the current in the RL is marked here. This current is equal to I, and we can say that I is equal to V0 by RTH plus RL. See, in this circuit, the current from the circuit is total voltage V0 divided by sum of the resistances RTH plus RL. That is, I is equal to V0 by RTH plus RL. If we know I, then power, that is power delivered to the load, power consumed by this load RL from the source is equal to I square RL. I, we obtain V0 by RTH plus RL. So substitute the value of I in this equation, V0 square by RTH plus RL and into RL. Our aim is to find the maximum power delivered to the load from the source. It is the equation for power delivered. So to obtain maximum power delivered, we are differentiating and equating to 0. Okay, we are differentiating and equating to 0. We are differentiating the power with respect to resistance. After differentiation, that is, this PL value is substituted here, and after differentiation, we obtain RTH is equal to RL. This is very important result. That is, maximum power transfer theorem states that from a source to the load, maximum power is transferred from source resistance is equal to load resistance. See, this RTH is the source resistance, RL is the load resistance. From this equation, we obtained that maximum power is transferred from source to load, then source resistance equal to load resistance. That is the maximum power transfer theorem. Next, our aim is to calculate the amount of maximum power transmitted or amount of maximum power transferred from source to load. To get the value, we are substituting in this equation. Here PL is equal to V0 square by RTH plus RL into RL. We know that at maximum power transfer, RTH is equal to RL. So the equation changes V0 by RTH plus RTH whole square into RTH, and the result is V0 square by 4 RTH. So we should know for maximum power transfer theorem, maximum power transfer is occurred when source resistance equal to load resistance, and the amount of maximum power transferred from source to load is equal to V0 square by 4 RTH. Now one more thing, power is transferred from this source to load. Okay, and the amount of power received by the load is equal to V0 square by 4 RTH. Maximum power received by the load is equal to V0 square by 4 RTH. But at maximum power source is equal to 2 into V0 square by 4 RTH, that is V0 square by 2 RTH. Once more, during power transfer theorem, maximum power delivered to the load from the source is